Good day. This is Cherry Kaswat from Computer Engineering Department of Technological Institute of the Philippines, Manila. I'll be presenting the study that we have conducted entitled A Development of Fuzzy Logic Expert-Based Recommender System for Improving Students' Employability. So these are my co-authors, Dr. Enrique Pestijo, Dr. Ahmad Sadhikin Mod Isira, Dr. Alvin Saraga Alon, Engineer Jeneline N. Mindoro, and Engineer Julie Ann Bisusa. Employability. So employability becomes the part or the primary concept in many countries around the world, and it drawn the attention of the researchers and the industries also. So it becomes the duty of the higher education institution to provide or to produce a qualified workforce to the labor market. That is why the higher education institutions nowadays places emphasis on developing job-related knowledge and skills. However, it is still unclear to what degree students' qualification fit the demands of the industry or the employers. So most of the higher education institutions around the world or in the globe today are evaluating their strategies and of enhancing the employability of their students and introducing different ways to improve and strengthen it. So identifying students' employability and recommend the areas to improve their employability before graduation will increase the chance to be employed if the students will develop the employability skills. So in the previous researches of the other researches conducted by other researchers, they were able to determine what are the predictive or the most predictive features among employability skills of undergraduate students. But these researchers were not able to identify or to recommend what are the areas the students need to improve their employability to become more hireable or employable. With that, we come up with the following objective. So to create a system that will determine if the student is employable or less employable, and to recommend or to identify the areas the student need to work on to become more hireable. So first, what we did is we had this data gathering or the data collection. So the data sets that were collected in different department or agency in the institutions like registrar, career center or placement office, and guidance and counseling testing center. So the data sets has the following attributes. So elective track, program, mock job interview, OJT grade, final grade. So for elective track, these are the courses or the subjects that serves as a specialization of the student in their program. And then for the mock job interview, so these are for those who are enrolled in the on-the-job training course. So before they have their interview in the company, they need to undergo the mock job interview. And this OJT grade and final grade. So OJT grade is the student performance rating of the student given by the immediate superior in their company where they are being deployed. The next is pre-processing of data. So these are the techniques that we have used in pre-processing of the data sets. So we have this merging of data sets and we have this data normalization. So merging of data sets, so different data sets that we have been collected to the different department in the institutions were being merged. And these merged data sets were used in the experiment. And then for data normalization, we use data normalization for the missing values in the row or columns in the data sets. So we use the mean of the observation to supply the missing values or missing information in the row or in the column in the data sets. The next is the fuzzy logic development. So figure 2 shows the proposed FASI-based expert system for prediction of students' employability. So we have these input parameters: elective crack, mock job interview, on-the-job training grade, and the point grade. So this will undergo the pacification or this pacification. So since FASI rules are in linguistic forms, so the FASI input and output variables must assign to the corresponding linguistic values. So the table 2 shows the FASI variables and input and output and its equivalent linguistic values, which is entered in the FASI inference system in developing the FASI model. So the type of the membership function, it depends on the actual application. And in this study, we use the trapezoidal curve, which depends on the 4 parameters, which is shown in the equation below the table 2. The next is the FASI rules. So for the FASI rules, the academic and the career advisors of the Career Center and the expert in the field were interviewed before the construction of the rules. And they are also asked, which serve as the basis to build the FASI model. And then next is the defasification. So in this study, the proponents use one of the most popular defasification method in the FASI logic, which is known as the center of gravity or the COG, where the output relates to the center of the gravity of the surface of the membership function, characterizing the FASI set that resulting from the accumulation of the implication results of the student's employability recommender system or SERS FASI inference system in mom-dummy type, where the end method is mean using the center of gravity. So for the results, so we use to evaluate the performance of the model, we use the root square mean error and the mean absolute error. So table 3, which is the performance evaluation of the model, it shows the performance evaluation model where the value of the training set to the test set, if you could notice, decreases as the predictive accuracy measure. So the result shows that the developed FASI model performs a high predictive accuracy based on the computed mean absolute error and root mean square error scores, which decreases from the training to the validation and to the test sets. So the proponent's basis in accuracy of the mean absolute error and the root mean square error metrics based on the study that is conducted by the researchers of career track recommender system. So they use the RMSE as a performance metric. So they concluded that the decrease of the RMSE metrics from the training set to the test set, the predictive model improves, which indicates that a smaller value indicates a less difference between estimated and actual values. So the sample GUI was also shown in the screen. So that is the sample GUI where the student's information will be entered in the system and it will predict if the student is employable or less employable. And it will recommend what are the areas that the student need to improve to become employable. So for the conclusion, the proponents concluded that this FASI-based method in this study was very useful to undergraduate students in overcoming the difficulties of employability. Although numerous parameters are weighed, therefore, filtering methods are used to exclude unnecessary student attributes, resulting in using just 4 important attributes only. So different measurement parameters such as mean absolute error and root mean square have also been used to calculate the model accuracy and help the predictive accuracy, which result into high based on the test because the measured values were close to 0. So for future researchers or future research, the proponents realized in this study that the system needs to be validated or assessed by the users in terms of the level of acceptability for further study. And also, the future researchers can improve the system using the same set of parameters for enhancement and more research as chosen. Student characteristics are subject to change because major variables from real data will also change. And for and also the online version of the employability recommender system needs to be created and introduced in the future to allow students to use it anytime, anywhere. So these are our references, some of our references. And that's all. Thank you for listening.